Today we are going to learn about tree data structure. We are going to see its basics. It is the definition of a tree is the tree is a nonlinear data structure which organizes data in a hierarchical structure, and this is a recursive in definition. Supposedly, if we take a node A as a tree, root of the tree, and it has two children B or C again, so B and C are subtrees again, means they are form a trees again. So this is the recursive definition of a tree. So one of the thing is that it cannot have a loop. So basically, in a tree there are basically no loops or circuits. There are no closed paths. So another definition of a tree can be a graph without circuits. Some of the important properties of tree are that there is one and only one path between every pair of vertices in a tree. So if you take two vertices, there is only one and only one path between them. A tree with n vertices has exactly n edges. So if there are 7 vertices, there will be 6 edges. A graph is a tree if and only if it is minimally connected. That is, the minimum number of connected graph can be called as a tree. Any connected graph with n vertices and n-1 edges is a tree. So if you are taking a graph, any normal graph, and if there are n vertices and n-1 edges, then it's a tree. Then we come across some of the terminologies. The first node from where the tree originates is called the root node. So the tree originates from the root node. The head node is the root node. The connecting link between any two nodes is called an edge. So if there is a connecting link between two vertices is called an edge. The node which has one or more children is called a parent node. So a parent node is basically the father of two children. The node which is descended from some node. So a node which is descended from a parent is called a child node. The degree of a node is the total number of children of that node. So if you take a node and if you count the number of children, it becomes the degree of the node. The node which does not have any child is called the leaf node. A node which does not have any child is called the leaf node, or it can be called as the external node also. Total number of edges that lies on the longest path from any leaf node to a particular node is called the height of a tree. So if you count the number of edges from the leaf node to the particular node, supposedly the root, then you can call the total number of edges as the height of the tree. The total number of edges from the root node to a particular node is called the depth of a node. So if you count the number of edges from a root node to a particular vertex or node is called the depth of a node. So height is basically a bottom-up approach and depth is basically a top-down approach. We'll see an example. So you see A is the root node. C's degree is 2 because it has two children. The height of H is basically 0. See, height is 0, but the depth is 2. So if you count the number of edges from the root node, it is 2. H is also a leaf node. H and I are leaf node. Again, in here, you see B, its height is basically 2. So if you count from this one, leaf node I, 1 and 2, its height is 2. So the degree of B is 3 because it has 3 children. The depth of B is 1 because if you count from A, it has only one edge. From A to B, that is only 1. So again, we are counting the number as so we categorize tree as per their number of children. So if a tree is a rooted tree in which each node has no more than n children, rooted tree means it contains of a root, and if it has n children, it is called a n-ary tree. So if it contains only 2 children, at most 2 children, it is called a binary. If it contains 3 children, ternary, like that it goes on. A binary tree is a special type of tree in which every node or vertex has either no child node or one child node or two child node. That means it should have either 0 or 1 or 2 but not more than 2. A binary tree is an important class of trees in which the node have at most 2 children. Maximum it can have 2 children. That is the property of a binary tree. What is a binary search tree? So the binary search tree is a category of binary trees where the properties are such that the left subtree of the node contains only nodes with keys lesser than the node's key. So if you take the root, all the left subtrees of that root will contain values lesser than the root. The right subtree of the node will contain only nodes with keys greater than the node's key. That means all the values that are the right subtree will contain values greater than the root. The left and right subtree each must have so the left and subtrees are again binary search trees again. So we complete our lecture in here. We'll see lecture 2 next time.